Hello, good morning everybody. Welcome back to my Tom Lee tutorial. Today I will show you how to use the different methods of mathematical proof to prove that the submissions of I equal 1 to I equal n of I is equal to n multiplied by n plus 1 over 2. We can prove by induction, deduction, contradiction, or exhaustion. We can use different proving methods depends on what statements we want to prove. And so before we doing the proof by induction, contradiction, exhaustion, or deduction, we have to know what is meant by mathematical proof. So what is a mathematical proof anyway? Actually, a mathematical proof is a deductive argument for a mathematical statement, showing that the stated arguments logically guarantee to be true. For example, we want to prove that the summations of I equal 1 to n of I is equal to n multiplied by n plus 1 over 2 for any values of n belonging to the real number. If we want to prove that the left-hand side is equal to the right-hand side, we can use different methods to prove this. One of the methods is proved by the induction, and the other is contradiction, deduction, and exhaustion. And if we want to learn to prove by induction or contradiction or other methods, the better way is to do by example. So in this tutorial, I'll give you some examples to do the proof by induction and proof by contradiction. And I will let the proof by deduction and exhaustion in another tutorial. So are you ready? We jump to an example to prove by induction. Question 1. Prove that the submissions of R equal 1 to n with R is equal to half of n plus 1. What this means is we have a series 1 plus 2 plus 3 plus 4 plus to the final terms n is equal to the half n plus 1. In this case, we use proof by induction. Step 1. When n equal to 1, the left-hand side is equal to 1, and the right-hand side is equal to half n plus 1. This is half of 1 plus 1. This is half of 2 is equal to 1. And we assume that this is also true when n equal to k, and then we have 1 plus 2 plus 3 until k is equal to half k plus 1. And when n equal to k plus 1, we want to prove the left-hand side is equal to the right-hand side of the equation. So we have the left-hand side and the right-hand side equation as follows. On the left-hand side, we add k plus 1, and on the right-hand side, we substitute k by k plus 1. We got this form. And now from the above, we can see that 1 plus 2 plus 3 until plus k is equal to half k plus 1. So we rewrite it to half k plus 1 plus k plus 1. The right-hand side remains the same. And we can see a common factors of k plus 1 here. So we take out the k plus 1 and the half. The first term will remain the k, and the second term we have to multiply by 2 in order to divide by 2. So we have this one is 2. So you can see now the left-hand side is equal to the right-hand side. It's proved. And this is the way how we do the proof by induction. I will give you another example to let you familiar with the proof by induction. Question 2. Proof by induction that 1 crib plus 2 crib plus 3 crib to the n crib is equal to n squared multiplied by n plus 1 squared divided by 4. Step 1. When n equal 1, the left-hand side is equal to 1 crib equal to 1, and the right-hand side is equal to 1 squared, 1 plus 1 squared divided by 4. So it's 1 multiplied by 2 squared divided by 4 is equal to 1. So it is true when n equal to 1. And then we assume that this is also true when n equal to k. We have the following. On the left-hand side, 1 crib plus 2 crib plus 3 crib plus 2 the terms of k crib is equal to the right-hand side. K squared multiplied by k plus 1 squared divided by 4. And now when n equal to k plus 1, we have to prove that the left-hand side is also equal to the right-hand side. And we write down the equation, the left-hand side and the right-hand side. On the left-hand side, we add the term k plus 1 to the power of 3. And on the right-hand side, we substitute k plus 1 into k of the above equation. We have k plus 1 squared multiplied by k plus 1 squared divided by 4. We have to prove that the left-hand side is still equal to the right-hand side. And from the equation above, we know that 1 squared to the terms k squared is equal to this one. So we substitute this one into this equation. We have k squared, k plus 1 squared over by 4 plus k plus 1 squared is equal to the right-hand side. And we add up the left-hand side, we have this equation. And we multiply by 4 to cancel out this 4 in this equation, we get the following. Now we expand this term out, we have the left-hand side like this. And we multiply this term into the bracket here, we have k to the power of 4 plus 2k squared plus k squared plus 4k squared plus 12k squared plus 12k plus 4. We add up the similar terms. And the left-hand side is equal to k power of 4 plus 6k power of 3 plus 13k power of 2 plus 12k plus 4. We do the same thing for the right-hand side. And let's see if they are equal. The right-hand side is k plus 1 squared multiplied by k plus 2 squared. So it's equal to k squared plus 2k plus 1 multiplied by k squared plus 4k plus 4. And we multiply each term to each term in this form. We get k to the power of 4 plus 4k squared plus 4k squared plus 2k squared plus 8k squared plus 8k plus k squared plus 4k plus 4. And we add up the similar terms. And we get k4 plus 6k3 plus 13k squared plus 12k plus 4. And then you can see from the left-hand side we get this, and from the right-hand side we get this. So now the equation, the left-hand side is equal to the right-hand side. We have proof. This is how we prove by induction. Get a summarize here. Step 1, let n equal to 1. We got it is true. And assume that it is true when n equal to k. This is the assumption. And then when n equal to k, the left-hand side and the right-hand side, you get an equation. And we want to prove that left-hand side is equal to right-hand side. And finally, we have proved. Okay, that's enough for proof by induction. And the next example, I will show you how to prove by contradiction. And by now you have understand how to prove by induction. And the following example, the question 3, I want to tell you how to prove by contradiction. But before that, you have to learn what is proof by contradiction. Let's see the definition of it. Proof by contradiction is that we want to prove something. Let's say phi is true. We assume this not phi is true, and then we want to prove not phi is true. If we cannot prove that means phi must be true. Then we find some contradiction to our assumption of not phi is equal to true. And then we claim that not phi is equal to phi, so that phi must be true. Since not phi is not true. I think you feel some confusion about the proof by contradiction. So let's jump to some example and let you know how to prove by contradiction. Proof by contradiction that square root of 2 is irrational. In this question, before you prove square root of 2 is irrational, you have to know the definition of rational and irrational. The definition of rational number, for example, a number k can be represented by two numbers a over b, which a and b is the lowest term. Okay, after we know that's what is meant by rational, so if we want to prove square root 2 is irrational, we assume the opposite. We assume that square root 2 is rational. This means square root 2 is equal to a over b, where a and b are the lowest terms. Then we take square on both sides. We have 2 equal to a squared over b squared. That's 2b squared is equal to a squared. In here we know that if a squared is even, a must be even. Because from the above we have a squared equal to 2 multiplied by something, so a squared should be even and a must be even as well. So if a is even, we can represent a by 2k, and then we have 2b squared is equal to 2k to the square, and 2b squared is equal to 4k squared. Therefore, b squared is equal to 2k squared. Then b squared is even, so b must be even. And let's go back to our assumption. We assume that square root 2 is equal to a over b, where a and b are the lowest terms. And then we get now square root 2 is equal to a over b, where a is even and b is also even. That means these two terms, if they are even, they cannot be the lowest term. So what we find is that something is contradicts to our assumption. And we can conclude that square root 2 equal to a over b, where a and b are lowest term, is wrong. So square root 2 is rational. This is false. And that square root 2 must be irrational. And then we prove. And this is called proof by contradiction. So we conclude all the steps with proof by contradiction. If you want to prove square root 2 is irrational, we assume the opposite. That means we assume square root 2 is rational. And then we find that there is some contradiction in here. Therefore, our assumption square root 2 is rational must be false. On the other words, that means square root 2 must be irrational. And then we have proof square root 2 is irrational must be true. This is how we prove by contradiction. So I think this is all for today's lesson. I will give you some examples. Let's see you can do it by yourself. One of the examples is proof by contradiction. You want to prove A intersects B intersect A minus B is an empty set. Another question is that you want to prove 1 plus 2 plus 2 squared plus to the 2n minus 1 is equal to 2 to the n minus 1. And this one you prove by induction. So that's all for today. I hope you liked my videos. If you liked it, please subscribe to my channels. Thank you, goodbye, and have a good day. Adios, hasta la vista.